Okay. So now we will start about the Hadoop introduction, and let me explain you little bit about big data, and then we will talk about Hadoop core components, Hadoop ecosystem, and also a difference between traditional relational databases such as Oracle and Hadoop. So we will cover these topics in this session, and then we will get into cloud distribution of Hadoop, setting up the cluster and all those things. Okay, the history of big data is so when Google want to develop the search engine, they started with MySQL. And if you see, Google is when they started Google, when internet is gaining momentum, from that time they are scraping all the websites that are available in the internet, and they are providing a search engine on top of that to search whatever is relevant to you. And for that, they started with traditional database like MySQL for their search engine, but soon they hit the threshold, and scalability was a major issue. Because I will give brief overview why scalability is an issue with traditional databases, and then we will see what Google has done to overcome that issue. Okay, I have to do whiteboard, so I'm opening the whiteboard now. So let's take the example of Oracle database, okay, which is a traditional database, and it supports cluster environment. So you can have multiple databases to process to support same application, multiple database servers to support the same application. So you will have a database layer. Database layer will look like this, and then it will be connected to application servers. Okay, and then after creating the database server, DBS will give you a service or JDBC URL. So from application servers, you will use this JDBC URL to connect to your cluster. Okay, and this is your clustered database. So there can be more than one database server to support your application. And then to facilitate this clustered environment, they have to go with network storage, because when it comes to traditional database, it is developed based upon code rules to support transactions for the core business of the enterprises. So, for example, if you take about a bank, and when you go to a bank, and when you withdraw the money, it has to deduct from one table in the data model, and it has to add to some other table in the data model. So, and all these operations have to be done in coordinated fashion. That is called as transaction. So, multiple operations that needs to be done in coordinated fashion is called as transaction. And RDBMSs like Oracle came into picture to support those transactions. So, to facilitate that, when we use multiple database servers, the data has to be mounted onto all the database servers. So, which means we have to use network file system, not the local file system. So, if you want to use Oracle clustered environment or any other database with clustered environment, we have to go with network mounted storage. Okay, so network mounted storage means there will be a rack, RACK, where you can add as many hard disks you want, and then you can create a logical layer on top of that. And this storage, this logical pool on top of all these hard disks will be mounted onto all the database servers. Okay, so this is how it will be done, and the way they will mount is by using a switch. So there will be a switch, and the storage will be connected to the switch, and all the database servers also will be connected to the switch. Okay, that's how, and then they will mount the storage to these multiple databases. So in this case, what we need to understand is the same storage will be mounted to on all the database servers, and as it is network mounted, even though you have a lot more capability now, your network switch can be an issue for scalability. And also for transactions to be done in coordinated fashion. If you are familiar with Oracle, there are something called global locking and queuing mechanisms. Global locking and queuing mechanisms. Okay, and because of this global locking and queuing, the scalability cannot be linear in for any of the use cases. So what I'm trying to say is, when I say not linear, scalability is not linear. So let's put it in a chart, okay? And this is the number of database servers, and this is number of users, okay? So if, let's say, if one database server can support 1,000, 1,500, 2,000, 2,500, 3,000, etc. So let's say one database, a single node database can support 1,000 users. Okay. When you add 2 nodes, it can scale, but it cannot scale linearly for any of the use cases in the application because of the issues which I have spoken earlier. So ideally, if it scales linear, it should be able to support 2,000 users with a two node cluster. But due to the challenges I have explained earlier, like network and also these global queuing and locking mechanisms to do transactions in coordinated fashion, it will be able to support probably only 1,600 users. And then when we add another node and made a 3-node cluster, ideally it should have supported 3,000 users, but it might support only 2,000. Okay, and in some cases, the more database servers you use, it follows. This is called a law of diminishing returns. The more servers you add, it will not scale linearly, and the returns will be diminishing, and it will actually hit a threshold, and it will come down like this. So a similar approach is used, not the same, but similar approach is used for Google to support their search engine to scrape all the web servers and then store in database tables, and they hit the wall after building, I think, 1,000 or 2,000 node MySQL cluster. After that, if they try to add more nodes to the cluster, it is not scaling anymore. The performance is actually going down. So when they hit this issue, they develop a completely different solution, and at that time there is no reliable distributed framework. So they come up with their own frameworks and applications, and they came up with the GFS, which stands for Google File System, and then Mapreduce, and which is for distributed processing. So GFS is for storage, which is a distributed file system, and Mapreduce is distributed processing framework, and Bigtable is a index. So I will explain what they are again on the whiteboard. So when you think about it, right? So how Google works. So if I open the Google web page, when I search for, let's say, NoviSync, or let's say big data, okay. So it will give you the results that are most popular at that point in time. Probably there might be some latency, but depending upon the pages that are visited, the first page will be, so it is called a page ranking system, and they will rank the pages, and they will display the pages as per the rank based upon the keyword you have typed. So that is how Google works. So to provide this in real time, they have to pre-process a lot of this data behind the scenes. Okay. So they have to go through all the web pages, and then they have to build some data structure where that results have to be stored. So there are no solutions in conventional technologies. So they come up with these three things: distributed file system. So when they scrape all the web pages, like novisync.com or apache.com or any other website, they need to do the batch processing, and they have to store data in a distributed fashion, and then they have to do the processing in distributed fashion so that it can scale depending upon the usage in the depending upon the internet usage, and then the output has to be stored in some fashion where it can be searched very quickly. That is called as indexes. So it has to be indexed based upon all the important keywords. So probably there might be an index entry in Google table structures, which stands for big data, and it might have values, all the top websites as values, and it might be showing the results from there. So these three will serve the purpose. So I'm going back to the presentation. So first one is distributed file system. So when it actually scrapes all the web pages, the content of the web pages will be stored in distributed fashion, and then the MapReduce will be used to do the processing, and the output of this MapReduce will be stored in Bigtable. So Bigtable is nothing but indexed table of key and value pairs, and your search key will be the key, and all the pages will be the value. So when you enter the key, as it is already sorted based upon the key, it can find out where this key is, and it can show the results as soon as possible. So that is how it works. And I will explain in layman terms as well how it works, so that everyone understands the rationale behind this, especially the first two components. So in this presentation, the distributed file system and distributed processing are the ones which we'll be talking about in detail, because Hadoop is developed for those two things. Okay, and then Bigtable comes into picture with respect to HBase, which we will see later. But for now, we will talk about DFS, which is a distributed file system, and the MapReduce, which is a distributed computing framework. Okay. Now let me explain in layman terms how it works. Okay. So let's say everyone might be able, everyone know about playing cards, right? So let's say you have a large deck of cards. Okay. So there are hundreds and thousands of cards in this deck. Okay. And using your traditional system, if you try to store it in the database, it will be stored in as a single table. And typically, if you want to do the count, especially so in the deck of cards, we have three attributes. One is color, red and blue, and then sweet, which is heart, diamond, those things, and then pip. These are numbers from 2 to 10, and J, Q, K, R. Okay, so you have this deck of cards, and you can visualize the traditional database system like this. Okay, if you want to do the count of cards, each database server can be treated as an individual, and the storage is the deck of cards, and then he has to read the entire deck, and serially has to count how many cards are there. Okay, and when it comes to Hadoop, if you want to distribute the cards, first you have to divide the data randomly. So instead of doing the count like this, let's say there are now we have 16 people in the class, let's say, and I want to use all the 16 people to get the count. So there are 16 people, like that. We have 16 people, and what I can do is I can randomly divide this deck and give a piece to each person. Okay, so there will be 16 such. 16 such piece of this large deck distributed across all the nodes in the cluster. And now to get the count, I can use all these people. So there will be a master who will coordinate the distribution and also to aggregate the counts that are coming back. So this distribution is distributed file system. So I am actually distributing the deck of cards with all the people. Okay, and that is GFS. Google File System is this one. It will actually distribute whatever data you have across all the nodes in the cluster. And then to process the data, in this case, processing is to get the count of this entire deck. And this person is capable of both storing and also count, because if he is a human being, he can have deck with him and also he can do the count. So the first one is storage, and the ability to count is processing. So this guy can do the. Can everyone go on to mute? Okay. Yeah. So the first piece is Google distributed file system, and now we are talking about distributed computing. Each individual can, so as a master, I can have the details about how this file is distributed. Okay, so the master is capable to understand how the file is distributed, and also when it is actually processing the data, this individual node can actually do the count on the data which it has, and then he can pass on the count to the master, and then that master can aggregate the results of each individual count provided by each individual, and he can compute the total count. So that is about the distributed file system and distributed processing. And that's how Google have achieved in storing the huge content that is scraped from internet in distributed fashion, and then do the page ranking by processing the data using all the nodes in the cluster. Okay, so we will see again the difference in technical terms later, but in layman terms, this is the main difference. So using traditional systems, you will have one table like this. Let me highlight this. One table like this, and then the database server has to get the entire data set, and he has to do the count, whereas with Hadoop, we can do it in distributed fashion. Any questions on this? So let me go to the next slide.
Durga, this is Manoj. One question. So
yeah,
how do you decide what is optimal? Like you said, 16 nodes in the cluster, right? So you cannot. I mean, I don't know if it is you can keep adding the clusters infinitely and distributing the data across the infinite nodes, right? Then the aggregation becomes complicated, right? Like, is there then we follow some like logic or rule to ideally find out the number of nodes in the cluster?
No, the thing is, if you think about it, right, there are multiple, when you run a query, like select count of, let's say there is an employee table and department table, and you want to get the count by joining these two tables, group by department number. So in each department, if you want to see how many employees are there, you group by department number, you will try to get the count, and also you will try to order by in some logical fashion, right? So if you decipher that query, there is a filtering involved in it. There is a sorting involved in it, because to group the data, it has to be sorted, and then only it can group. Okay, so for any organization, you can divide the use cases into filtering, grouping, sorting, joining, etc. So when it comes to filtering, you can scale linearly. You can even add, there is no threshold. You can scale as so the more data you start getting, you can add the data centers, you can add more and more nodes, and you can scale it. Filtering can be scaled, but sorting cannot be scaled linearly. Using this system, you can come up to you can scale up to the threshold. So you can get a lot more scalability in sorting, but it cannot be scaled as like string. I will explain all those things later.
Okay.
But theoretically, if you think about page ranking system of Google, you can scale it infinitely. You can add hundreds and thousands of nodes, and it can still scale. And the way they do it is they have multiple data centers in multiple countries and multiple states, and each data center will try to process its own data, and that's how they scale actually.
Okay. Okay. So, but all your data is distributed across the nodes. Like you said, right? One question, probably the basic thing that I'm coming into my mind is like, let's say you have 1,000 cards in the deck, right? Is that necessary to distribute these 1,000 cards into all 60?
No. Yeah, we will see those things later. But for now, to answer your question, the chunk we talked about, right? The size of the chunk is 128 MB. So if the file is more than 128 MB, then only it will be distributed. Okay. That is called as block size. And also there is a concept of replication factor, and I will talk when we actually talk about Hadoop in technical terms.
Okay.
Yeah, Chintan, tell me.
So few questions. One is can we use big data for the relational stuff that we used to use it in SQL or Oracle?
Yeah, it's a good question. So let me explain you that should be answered. So let me explain you what is the role of big data for an enterprise. I will not take long time. I will just explain. Okay. So let's say you have an organization. So typically you will have two types of applications, right? One is OLTP. I hope everyone understands this. If anyone have any question about OLTP, just ping me in chat. I will clarify. If you do not ask, I will assume that everyone understands that. And then there is DSS. DSS is Decision Support System, and typically we hear terms like Enterprise Data Warehouse, DSS. And then there are other kind of applications for integration. But integration is typically between the organizations, but within the organization, or between the departments within the organization. But you can discard the integration for now. Okay. OLTP is online transaction processing. So the example which I have given earlier of going to a bank and withdrawing money is a transaction because it has to deduct amount in one place and add in another place so that you can have a month-end statement about the status of your account. Okay, so that transaction to withdraw the money has to be implemented using online transaction. OLTP stands for online transaction processing. So that's where the RDBMS and all those things comes into picture. So for those kinds of use cases, you will build OLTP systems with the architecture which I have defined earlier. Okay, and the characteristics of OLTP is real time. So when you and also it has to be very fast. You have to get the when the teller in the bank withdraws the money, it has to be reflected immediately. Okay, so the money has to be deducted from the account immediately, which means it is real time. And also the second characteristic is transactional. When I say transaction, so reducing money from one table and adding money to another table in a coordinated fashion is transaction. And it has to be done, it has to be saved or it has to be rolled back. Okay, you cannot save in between, then it will be in inconsistent state. So in some cases, if the teller failed to draw the money, then the transaction which is started has to be rolled back. So that is called as commit and rollback. So the characteristic of OLTP is transaction. So it is real time, it is transaction, and it is online. That's why it is called as online transaction processing, because you have to be when he is online, he has to see that immediately. Okay, so that is the characteristics of OLTP. And to support from the database point of view, I forgot the first name. There is a guy called Cod. He come up with Cod rules, and based upon that, databases like RDBMS, databases like Oracle, Informix, MySQL, all this came into picture. Okay, and these are capable to support those kinds of use cases. And then there is for an organization, all the core business will be implemented using OLTP. So for a bank, the teller applications that support teller are core to the banking system. So they are considered as OLTP. And then decision support system. So for example, if it is a retail client, and if the executive management want to see the dashboard of how much sales have happened within the last 1 year in each of the states in US. So for example, organization like Target, if the executive management want to see how the sales is at each state level, and want to make some decisions, those are called as DSS, and they are decision support system. And DDW is the term which is used in this context, where you can get the data to run those reports. So we, for a given organization, we have OLTP and we have decision support system. So for OLTP, systems like databases like Oracle, MySQL, etc. will work. Okay, but decision support system, these do not work very effectively. They will work on small size of data sets, but on very large data sets, they will not work. That's where systems like Teradata and many other data appliances came into picture. Now, what's the role of big data in this? So, because of smartphones and internet, as I mentioned to you, like Google, we are getting lots of data from the external sources. So for organization, now there are new types of use cases that are coming to picture. For example, customer analytics. Okay, so decision support system is for executive management. So the users for decision support system are very few, and it has to process a lot of data and publish as a report. Whereas customer analytics is to publish reports at each user level. So for example, I have the Technology Mentor YouTube channel, okay, and how about the other guys? Can you guys hear my voice? Yeah, I think Shilpa, it is only issue with you. I'm not sure. Probably are you? Oh, sorry, I'm talking even she said, are you listening through the audio or phone?
Hey, Durga, I just want to inform that I had the same problem, so I closed the Apex and again reopened it. It worked for me, the audio. So if anybody having a problem, they can try the same.
Okay, she can hear me now. Okay. So now, right, because of the internet, I want to see the analytics of how my channel is performing. So here there is a video manager, and I can see the analytics, and I can trend how my channel is performing, how many people are viewing in last 28 days, how many minutes watched, and how much I made, and also how each video is performing. I can see all these numbers. Okay, so now coming back to this whiteboard, if you think about customer analytics, right, the user base is very big. Okay, so these traditional enterprise data, these traditional decision support systems will not be able to support customer analytics like what I have seen earlier, shown just now. So big data can solve that issue. And if you think about it, right, for example, for a website like Macy's, if Macy's can provide how much people are spending, then it can add value to their business. I mean, if the customer can trend how much he is spending, then it can add value to the business. And also, if you are familiar with Mint, Mint is a Intuit product, and Mint, you can connect all your bank accounts to it, and it can create a dashboard for you, how much money you are spending over time, and it adds a lot of value for you to see consolidated dashboard of how much money you are spending in what categories. So that is called as customer analytics, and these traditional systems have issues supporting that. They cannot support it, and that's where big data comes into picture. Search engines, customer analytics, and also if you think about LinkedIn, LinkedIn have recommendation engines, job recommendation engines, endorsement, profile recommendations. All these things you need not go with these OLTP systems, because OLTP systems have issues to scale. And if you think about endorsements in LinkedIn and any other application, scalability is the main complexity. There are no transactions involved in that. Operations needs to be real time, and sometimes writes have to be real time, sometimes reads have to be real time. So in this context, these traditional systems will not be able to support. That's where big data comes into picture. There are many tools in big data which can solve these issues. So wherever transactions are important, big data tools in big data cannot fit. But if your use case is just operational and transactions are not that important, then there are tools in big data which can be a good alternative for this. So for operational use cases, now in the organizations, what is happening is this OLTP, it comes under operational. Okay. Earlier, they used to use whether transactions are important or not. They used to use the systems like Oracle to support their applications. Now they have an alternative. So if your use case is just operational but not transactional, then they can use the big data ecosystem tools. So big data ecosystem tools can solve multiple issues. They can complement existing traditional RDBMS databases for operational use cases where transactions are not important. They can work or complement existing support systems in the organization, and you can actually develop applications from scratch that are related to customer analytics and other advanced analytics. So that is the purpose of big data for an organization.
Cool. So awesome. I think I understand more clearly now. So one more question is, what if your OLTP is growing like anything? So you still need OLTP, but it's humongous. What approach we take it?
That's what, if your OLTP is humongous, I will answer that shortly. In most of the cases, the databases becomes huge because of the stale data. So you need to have the purging, mechanism to purge all the stale data, and then you can control the size of your OLTP databases.
Okay. Like take an example of Amazon, right? So Amazon.
Amazon does not use OLTP for most of the scenarios. They use something called DynamoDB for their catalog and all those things. Only place where they might use OLTP is when your transactions happens.
Okay, and then they move it to the Teradata or big data. After
that is right. That is right.
Okay. Cool.
But if you think about Amazon catalog that you see, that is again not it's an operational use case, but not transactional use case. Transaction happen only when you want to buy. Okay. So, so to display the catalog, you don't need to have a system like Oracle.
Got it.
Use, and they have their own product called DynamoDB, and they use that.
Okay.
And that can be considered as big data database, DynamoDB.
Okay, that makes sense. And last question to in a similar line, is there? I'm not sure whether you answered or not, but can you go back to the image that you the draw map? Is there any system right now or any ecosystem currently which can put the data in an operational, also in a DSS, or also in a CA? So I can define, like, I'm doing something, this data goes to the operational, and then, so let's say I'm creating an account and I might need only my customer ID as an operational because I'm going to do multiple transactions regarding that one, but all my address and all other information which is not important for the OLTP will go to the big data. Is there any mechanism or system already there who does that?
We will see that later. I think
Okay.
it is not important at this time. We will address that question later. Okay. So that is about big data, and the characteristics which I have explained earlier in simple terms are termed as volume, variety, and velocity. So what is volume? Volume is too much data to process. So if you think about Google GFS, the volume is too much. They scrape all the web pages that are there in internet. So the volume is too big. And variety is typically in traditional databases we deal with the structured data. So we have to define the structure to your data, and then you have to insert into the tables by passing the data to match to your structure. Whereas in big data, you can even deal with unstructured data. Okay, we will see that later. But variety stands for structured, unstructured, as well as semi-structured data. So tweets in Twitter or blogs are semi-structured because the blog post might not be structured, but the blog object is structured. It will have many other attributes which are typical to structured tables. At the same time, it also has blog content which is unstructured. So there are variety stands for structured, which is similar to our traditional tables. Unstructured, which are blog posts and tweets themselves, and semi-structured, which is the blog object or Twitter object. And then velocity is the speed at which you should process this data. So, for example, if Google cannot process, for example, when there is an election campaign, and if people are talking about Obama and McCain, and if they take 1 month to process the data, by the time elections will be already done, and then we'll start seeing the stale results. So velocity is key. So even though it's batch, it has to be able to process as soon as possible, and should show you the results as soon as possible. Okay, that is velocity. So if your use case falls under any two of these three categories, then it is most likely big data, and you have to explore the ecosystem and you have to come up with a solution. And then again, they are divided into batch and operational, but not transactional, which I have explained earlier. So I'm not getting into details. These are the characteristics which I have already explained. And when it comes to Hadoop, now we are talking about Hadoop. So within the big data ecosystem, you can divide them into batch as well as operational but not transactional. And for operational but not transactional, we will typically talk about NoSQL, which is mostly out of the scope except HBase. So HBase comes from Google Bigtable. I will explain about HBase more later. For now, I will focus on Hadoop. because we will start with Hadoop and then we will set up HBase after we understand what Hadoop is. So I will give more insights in Hadoop than HBase. So to process the data in big data in batch, we will talk about Hadoop with MapReduce and the GFS. So Google have published 3 white papers. One is on Google file system, second one is MapReduce, and then third one is Bigtable. So from Bigtable, they developed HBase. So people from Yahoo, Google, Facebook, and other organizations, they grouped together and they developed these open source tools like HBase, Hadoop MapReduce, and HDFS, and they incubated in Apache, and they started providing these technologies to the enterprises. So that's how this Hadoop came into picture. It is evolved from Google white papers. Okay, so now with respect to Hadoop, there are 2 core components. One is storage and the other one is processing. One related to storage and the other one related to processing. So HDFS, which stands for Hadoop Distributed File System, which we'll see in detail later, is for storage, and YARN or MapReduce is for processing. Okay, and this is how it will look like. So all the nodes in the cluster, we will have storage locally mounted. So if you look at my earlier pictures, this is how a database will look like, and data is network mounted to the database server. But here, storage and processing are locally mounted, and we will understand the purpose of it when we actually talk about MapReduce in detail. But for now, just remember that storage and processing are locally co-located, and we will see how it will benefit for the batch processing when we talk more about MapReduce. Okay, and this is how a typical Hadoop cluster will look like. There will be many nodes. These are, you can term them as slaves or agents. Slaves. They are termed as slaves, and each slave will have storage and processing configured on them. And then there will be masters. So this is master for storage, and this is master for processing. So it's a master slave architecture, and you will understand more about these components after we start talking, setting up the cluster and all those things. Okay, this is how it will look like. With for storage, we will use HDFS, and the masters, there will be masters for HDFS as well. And similarly, the term is called as data node. You need not understand these things at this time, but we will discuss about these things in detail later. I just want to start giving you terms so that you can memorize these things. And for storage, all the slaves will have data node, and name node and secondary name node are termed as masters. Okay, and for processing, I didn't give the details for processing. I just made a generic term called MapReduce because there are 2 architectures for processing. One is classic, which is being decommissioned or deprecated, and the YARN, which is latest and which will be implemented, which will be used going forward. So we will look into these details later. Okay, this is how the Hadoop ecosystem will look like. So far we have spoken about the distributed file system HDFS and distributed processing MapReduce. Okay, these 2 are core components because they developed both in tandem. And but MapReduce, as I have specified in this slide, is for batch processing. Okay, Hadoop with MapReduce is only for batch. You cannot do real-time operations using Hadoop. Using MapReduce. Okay, so they realized that they can leverage HDFS and have some non-MapReduce applications and deal with the data in HDFS in real time. Okay, that's why this non-MapReduce component came into picture. And when it comes to MapReduce, it is standard. Either we will use classic or YARN, For non-MapReduce, we might use many other frameworks. So we will see about these things in detail later. But for now, these two are core components, and on these two core components, there are functional tools like Flu, Moody, Hive, Pig, Sqoop, Mahout, etc. I will demonstrate a few of these tools today so that you understand the purpose of those things, and also I will demonstrate few of these things, few of the things about HDFS and Mapreduce, so that you can get a feel of it, and then we will start with setting up the cluster. Okay, and now we will talk about difference between Oracle and Hadoop. First, we will talk about Oracle architecture again, and then Hadoop architecture, and we will see theoretical differences between the two. So this is how we will actually set up your Oracle database. First, you will get the storage. So this is the storage rack, and these are hard disks, and the green rectangle on top is a storage mount point that is created as a pool to mount it onto one of your clustered databases. And then there will be a network switch. These are the database servers. So we are talking about 3-node cluster, and then this storage rack and these database servers will be connected to network switch, and this green rectangle will be mounted on all the database servers. And then you will have another network switch so that these three can communicate with each other for global queuing, global locks, locking mechanisms, so that transactions can happen in a coordinated fashion, as I have explained earlier. So this is how Oracle architecture looks like. Okay, and these are the technical terms. So you will have cluster of services with the same binaries and configuration, and all of them run the same backend process. So the backend process are SMON, PMON, etc. So as there are many DBS in this session, I'm getting into a little bit technical details so that they can differentiate Hadoop and Oracle, and they can learn quickly. And also this information is important for non-Oracle guys as well. For storage, we will use network file system, and it will be mounted to all the database servers. And software will be binaries that will be installed on all the servers. And then parameter files. So whether it is Oracle or Hadoop, anything, if you think about it, right, these are the components which will have. You will have servers, you will have storage, you will have software, you will have parameter files, you will have backend process, you have to configure your memory, so, and also you have to take care of the network. So these are standard things which you need to understand to deploy or build systems with any software. Okay. So now we are talking about parameter files with respect to Oracle, init.ora, pfile, fpfile, etc. The ones which you typically use. And then the backend process are these, SMON, PMON, etc. And memory will be same on all the nodes in the cluster. Otherwise, you will start running into issues. And also, there will be, in the backend process, there will be services like CRS to coordinate between the nodes. I should have added that as well in this list. But it will be same on all of them. It will have same backend process that will be running on all of them, same memory, and even the memory structures will be same, like PGA, SGA, and within the SGA shared pool database buffer cache. These things have to be configured same on all the nodes in the cluster, in the Oracle cluster. And then network, there will be typically 3 network switches, one for interconnect of nodes. So if we see here, so this is interconnect of for interconnect of nodes, and the other one for the connecting with storage. And there will be third network switch, where which will be used for public IPs. So typically, if application servers like WebLogic or any other application server or web server want to connect to the database, the IPs that are generated using the other network switch for public will be provided. So in a typical production system, we will at least have 3 network switches in most of the cases. We can run the show even with 2 network switches, but typically there will be 3. Okay, so one for interconnect of nodes, one to connect with storage, and one for public connectivity. And then this, now again I am coming back to Hadoop architecture. So here the storage is network mounted, but in this case, okay, I thought I have listed something like this. So I will update the slide similar to this. In most of the cases, it is same. Only difference is when it comes to storage, it will not be network file system. It will be local mounted file system, and backend process names will be different. Parameter files will be different, and configuring memory structures and all those things will be little different. But the fundamental principles are same. You just need to understand the subtle differences. Then you will be able to understand the technology very quickly, and you will be able to support it very effectively. You will understand all these things with respect to Hadoop by the time we complete the course. Okay, so again, this is the Hadoop ecosystem, and now I will do a demo, and then we will take a break for 10 minutes. Okay. So first, as part of the demo, let me talk about the Cloudera Manager. Okay. Okay, let me do this.
Durga?
Yeah, go ahead, Manoj.
One question, Durga. So when this Cloudera now we are going to this cloud basis provisioning on, right? Like for at least for this class it is fine, but in general I can see some of the cloud providers like Amazon or someone providing the Cloudera distribution, right? Like
yeah.
And in that case, how do we? I'm not sure if they really provide the local storage for the nodes. Because most of the times these cloud guys have shared storage, right?
Yeah, that's what. Let me explain you, okay? So when you actually try to create instance in AWS, once you select the instance, and let's say you select m3.large, okay?
Mm-hmm.
And then click on next, configure instance details, add storage, right? So if you want to add more storage, and if you click on this, there are multiple options. EBS, instance store 0, and instance store 1. So if you want to host your Hadoop system in AWS, you have to select instance store for your production databases, and you should leverage these instance stores. Instance stores are nothing but either local, or they will give you the performance of local hard drive. Okay, but the caveat is, but we are not using instance store because once you create instance store, you cannot stop the server. You have to terminate it.
Okay.
So you have to. So in case of production, you will not be stopping very frequently, right? You will be either rebooting or you will be keep it up and running. So you can provision instance stores in that case, and you can deal with it. And if you have to stop, you have to take the snapshot of the storage and then terminate it, rebuild it, and then you have to mount the snapshots, and then you will be able to live with it. That's how you have to deal. And most of the cloud providers have the same features, or similar features.
Okay.
Yeah. And it might not be as effective as on-prem physical servers, but it can solve 90% of the use cases with desired, because it can scale. Even the performance is little bad compared to physical servers. Still, as it can scale, you can get you can meet your SLAs.
Okay.
Okay. Now let me go back to So let's start with Cloudera Manager, and I have a 4-node cluster. Okay, you will understand the entire, this web page in detail by the end of the course, but I will only give an overview. So you can click on hosts, and you can see how many hosts are there in your cluster. So this cluster is having only 4 nodes, and the second one that is important for now is the roles. To understand what all roles are deployed on each of the nodes. And if you see, this 239 is gateway. I don't have any roles that are that says HDFS or Mapreduce, yarn, etc. Whereas when I say when I see in 240, I can see data node, name node, and secondary name node. And these are related to HDFS. You will understand those things. Don't worry about what they are. For now, just understand the difference between the gateway and the other hosts in the cluster. So I have 3 nodes in the cluster, which is used for HDFS and Mapreduce. Okay. And we will see. I will give demo of each and every of these services for now, and then we will see it in detail over the course. Okay, so this is about Cloudera. It will look like this, and we will see. We will understand completely in detail by the end of the course. And now we will talk about first HDFS, then Mapreduce. We will see a little demo, and then I will try to execute some simple scripts in Hive to tell you what the purpose of Hive is and how it works, and then we will go to the next topic. Okay, this is about Cloudera. Now we will see how to copy that data into HDFS and how it will be stored in HDFS. You will not be able to understand completely, but you will get a taste of it. So I am connecting to my cluster. This is not the 16 nodes which we have seen earlier. These 4 nodes are different. Okay, and okay, so there is a command called Hadoop, and we can use this one or another command called HDFS. So Hadoop is being it might be decommissioned. HDFS will, I think HDFS is the more important command which you need to focus, because if you see, there are a lot more features in HDFS than in Hadoop. Okay, so let's focus on one command under HDFS. We will see other things later. So if you are using HDFS, you have to use DFS to deal with your file system. So when you say dealing with your file system, in HDFS, to copy the data, to delete the data, those things are typical operations while dealing with the file system. And if you are using Hadoop, you have to use FS command. If you are using HDFS, you have to use HDFS DFS command. So it will look like this: Hadoop FS or Hadoop DFS. Sorry, HDFS DFS. Okay, and it will give you, it will give you all the options there are. So these are the options that are available. And if you see, HDFS DFS is also translating into Hadoop FS. So behind the scenes, Hadoop FS and HDFS DFS are same. Okay. And for today's session, we will just use a simple command called Hadoop FS put. Okay, and we will copy a 2 GB file, and we will see how the data is stored in HDFS. Okay. Okay, so there is a 2 GB file, and I will copy that file, and we will see what will happen. See, I'm copying it from node 239. Okay, and we will see how it will be stored in HDFS. You might not be able to get it completely, but you will get a taste of it. So I'm copying it as Hadoop. So let me first create a directory. User HD user novice sync. Okay, and I will explain all these commands, what mkdir is ls is in the next session. For now, I want to just show you how the data will be copied. So you can see the directory novicing here. And now let us lsltr. So Hadoop fs -put is the command to copy the file. And then you have to give the input path, which is large.txt, to make it more understandable. Let me give the full path rather than relative path. You can use relative paths also, but I will use full path. Hadoop fs -put and then I have to give the target location. So this is the local path. Local path in the sense the path in the 239, and this is the path in HDFS. Okay. So after today's class, you will have access to one of the if you can access VPN, there is a cluster which is already built on our lab on VM02 host 07. I will send these details in an email. You can use this link after connecting to VPN, and then you can connect to the host and you can practice. You can practice these things. Okay, and the host IDs also I have already provided in a host file, and you can practice these things if you are interested. If not, also that is fine. By next Sunday, you will get more details, and you can start your lab work from the next week class once we sort out all the VPN setup issues and all those things. Okay, and the directory where I want to copy in HDFS is novisync. As it is 2 GB file, it is taking little time. So as an administrator, you might not understand the APIs and all those things that will be used behind the scenes to copy this data. The thing you need to understand is how data will be distributed in Hadoop. You don't need to understand the programming aspects of it, but structurally you should understand how this data is stored. Okay. So now the file is copied. And you can again run Hadoop fs -ls command, user HD user novisync, and you can see the file. Okay, and now let us search for this file and see if the file exists any other location which have path novisync in that. Okay, on 239. So what I'm doing is I'm sudoing into root, okay, and find. Karthik, do you have any question?
Yes, actually I had a question, like, are we just trying to copy a file from one mount point to other mount point, or is there anything, something I need to know about this?
No. So there is a file. Okay, let me explain you. So if you look at it, I am in this location, home history user data. Okay, I am on 239. Okay, I am on 239. Can you go on to mute? I think you are on speaker. That's why it is echoing. If you get out of the speaker, it will be good. Okay, so we are under home HD user data directory, and there is a file here. Okay, and HDFS is a distributed file system. Okay, what I'm trying to do is I'm trying to copy a file which is in local file system to a distributed file system. Okay, let me run through these commands, and then we will address that question if you still have that. So there is nothing. Don't get into mount points. Just to understand from file perspective. So there is a file which is 2 GB local on this node, and we copied it to HDFS, and we will see where it is actually copied and how it is physically stored. Okay, so let me first show you that the file is not copied anywhere on 239 with the name largedeck.txt. Okay, so I am running find command and searching for largedeck.txt. There are only 2 files, and the path does not have no sync. So the file is not actually copied to on this node. I hope everyone is clear on that. And now we will see where the file is actually stored. Okay. So there are 2 ways to do that. For now, I will use the web interface to show that. When we actually install HDFS on Sunday, and we do hands-on lab, everyone together, and in that I will give you some important commands to see all these details from command line also. But for now, I will show from the web interface where the data is actually stored. Okay. So yeah, this is the database I am using, and this is the cluster I have used to copy the data. So when another important thing on this Cloudera manager is this home page. Under home page, you will see all the services, and we are talking about the distributed file system, which is storage. So I am clicking on that, and most of the pages, most of the services, the home page layout will be like this. And there will be web UI link in that if that service have web UI, and you can click on that, and it will come to this page. I will explain about this details of this page later, but you can click on utilities, and you can click the browse the file system. Okay. Now we will see where the file actually is, and what is the path we have used to copy. It is user HD user no vsync. Okay, so like Linux, even HDFS, which is a Hadoop distributed file system, which is logical file system, starts with root, which is / here. Okay, and then there is a directory called user, HD user, and we have copied to no vsync. So this is where we have copied, and you can see the file is there in HDFS. Now we will see what is happening. There are certain things which you need to understand. Size is 2 GB, replication factor is free, and as Manoj have asked me earlier, if there are only 1,000 cards in the deck, will it be distributed? Will it still be distributed? So the answer is no. 1,000 cards will not be 128 MB. So there will be only one there will be only one file associated with that 100 card deck. In this case, we are dealing with 2 GB, and the block size is 128 MB. So if you click on this largedeck.txt, and then there is a term called block. So the file will be divided into blocks, and the block size is determined by this. So block size is 128 MB. So 2 GB is approximately 17. Okay, that's why you can see block ID from 0 to 16. So this file is divided into 17 blocks, and most of the blocks is 128 MB. Block 0 is 128 MB, and you can go through the 15 and everything is 128 MB, but the last one, which is 16, is just 32 MB. So whatever left over is stored in the last block. So this is how the data will be distributed, and here you can see where the block is. So you can go through each and every node, and you can see.
Durga,
yes,
is there a way I can change the block size? Is that customizable or fixed?
Yeah, so we will talk about when we get into HDFS details. For now, I just want to give a taste of how each and every tool looks like. So I don't want to get into those details. Yes, to answer your question, we can customize it.
So, and one question, Durga, why other 3 nodes only used? The 4th one is the master. That's the reason it didn't store it in like 239.
So yeah, 239 is a gateway. So this is the standard to have a gateway. And there is a reason for that why you have to use gateway. I will try to answer it. Even if you do not get it, that is fine. We will see more in detail when we talk about Mapreduce in the later sessions. So the reason why you have to give gateway is you will configure HDFS, Mapreduce, and many other tools on all the nodes in the cluster. And also you have to submit the job. Okay. So to submit the jobs, you typically have to use gateway nodes. If you try to submit the job directly from the nodes that are participating in the cluster, then the process that submits the job and the actual tasks that will process the data can get into contention. So to avoid that, you need to have the gateway nodes, and from gateway nodes only you should be submitting the jobs.
So, but then if we have like multiple gateway nodes.
Yeah, we will have multiple gateway nodes. Yeah.
Okay. Because it's like a single point failure, right? Otherwise, that's the matter.
Yeah. We will have multiple gateway nodes, and coming to point of failure, we will talk about later. There is more than that to understand it. So we'll think about it later. But for now, that is right. We will have multiple nodes in the cluster. Multiple gateway nodes in the large clusters. Okay, that is about HDFS. Now, Karthik, does it answer your question or no? Hello, Karthik.
Hey, sorry, I was on mute. Yeah, I was on mute. Yes, please answer my questions. Yeah, please proceed.
No,
thank you.
No, I'm not talking about you, Karthik. Yeah, Karthik is clear. Okay, so now we will talk about Mapreduce. So HDFS is a storage, and Mapreduce have multiple components associated with it. One of them is programming. It's a very misleading term, and one of them is programming business logic using Mapreduce framework, and the other one is job management. And in this demo, I will just show you a simple Mapreduce job, how you can submit. And once that is done, we will take 10 minutes break, and I will demo other tools. Okay, so to submit the jobs, you have to use a command called Hadoop jar. Okay, and then you can give the jar file name. For administrators, this is not very important, especially at this time. You need not worry about how the program is coded, but you should see how the program is being executed. And if you see that there is a room for tuning, then you have to negotiate with developers to rewrite certain components and to scale the Mapreduce jobs effectively in the cluster. But for now, don't worry about that. I will just try to run a simple Mapreduce job and see what will happen. So let me do this. Okay. I have to use that TVF, sorry. Okay, the spelling is incorrect. Okay, so I will be running this program. So Hadoop, jar, training.jar. No need to worry, most of you might not understand this, but that is fine, that is expected. So, the logic of the program is to get the count of the cards in that large deck which we have copied. Okay. So this program takes two parameters. One is the input of the large deck which we have copied, which is user HD user novi sync large deck.txt and then output user HD user output dot novi sync dot output. Tested these things earlier. Okay, let me see.
You have to use it in a class path, Durga, -cp or something?
No. There is no need. I ran it. Let me. I think it's a runnable job. That could be the issue. No. That is fine. So this is how you typically run the job. We can simulate this using Hive also. So let me give a quick demo on Hive, and then we will see. So I am launching the Hive command line prompt. So this is how it will look like. Hive is again, if you go back to the to my presentation. So Hive is the ecosystem tool. Hive is the ecosystem tool, and can everyone go on to mute? Hive is the ecosystem tool which uses Mapreduce and HDFS. So you can look at this and determine what is the purpose of, means what is the underlying technologies each of these tools use. So Hive, Flume, Uzi, Pig, Mahout, Sqoop, all these tools are developed on top of HDFS and Mapreduce. And the Impala, HBase, Presto, and many other non-Mapreduce ones falls under this category. They are also considered as Hadoop ecosystem, but the only common point between these two is HDFS. So Hive is a Hadoop ecosystem tool which uses Mapreduce and HDFS. Mapreduce for processing and HDFS for storage. And then it uses SQL type of syntax to do the processing of data. So it actually uses MySQL, Postgres type of syntax. Okay. Don't worry about these command store databases, use cards, etc. I will explain those things when we actually talk about Hive in detail. And there is a table for large deck. So I will run a Hive query on top of it. So it will look like SQL. Okay, and it supports ANSI. There are subtle differences which administrators need not to be aware of. And I will cover all the topics which you need to be aware of. But whenever you set up Hive, you should be able to validate before turning out to the developers. So as long as you know basic commands in Hive, that is more than enough as an administrator. Okay, so I'm running a Hive query. So if you see, it is actually running a Mapreduce job. So the same logic, we can even write a Java program following using the Mapreduce APIs. Or if you run for those commonly used queries like getting a row count in a table or file, is a very commonly used use case. So Hive provide jar files for those kind of use cases, and you can use Hive interface instead of writing hundreds of lines of code. So let me open my Java program as well, and while it is running, let me show you the web interface to monitor it. Okay. So earlier I have shown you web interface for HDFS. Now I am showing web interface for Mapreduce. So these two interfaces are not related to Cloudera. These are provided by plain vanilla Hadoop. And this is how it will look like, and you can monitor the job. So what you need to understand is when you submit a Java program as a Mapreduce, it will be submitted as a job. And if you look at the map tasks, I will explain this about this web UI when we actually talk about Mapreduce in detail. But for now, let me just show you what is happening behind the scenes. Okay. So let us pick one of the tasks, and you can actually check the logs. Okay. And even before getting into logs, let me wait overview app. Should give details. Okay, that is fine. I will come back to this later. But now, okay, as it is submitting as a Hive query, it is not showing up the. Okay, that is fine. So this is how it will look like. Hive is nothing but SQL type of interface, which will translate your SQL queries into Mapreduce programs, and they will be compiled and submitted as jobs, submitted as Mapreduce jobs, and then it will be running against those. So in this case, one thing you can see is it is using 9 mappers, and we have 17 blocks. So there is a concept of split size, which it uses internally to club multiple blocks into to process using one mapper. You will understand all those things later, but typically there will be 17 mappers to process the data. If I have successfully ran that row count program earlier, you should have seen 17 jobs. So this is about Hive. And let us take 10 minutes break, and I will resume the demo of all these components. We will see what is Impala, what is HBase, and also we will see sample Sqoop command, Uzi command, and also we will talk about Hive web interface today, and then we will go to the next topic. Okay, so we will break for 10 minutes now. Okay, so for 1 minute, okay. So far we have seen how to copy the data, how to write a Mapreduce job, and how to run a Hive query. And let's see what happened when we run a Hive query. It took almost 95 seconds, and it have given the count. Okay, in some cases we have to see the results fast. 1 minute, okay.
So what is that? 163 whatever million, 16 million. Is that count on number of records or hits found, or it's records scanned?
Okay, I'm sorry. It took almost 96 seconds to just process 2 GB data, and that means even if there are only 1,000 records in a file, when you run a Hive query, it takes around 15 to 20 seconds because it is designed for it is designed using Mapreduce, and whenever you hear about Mapreduce, you should immediately translate into batch. So Mapreduce is synonymous to batch. So it is supposed to be used only for batch processing, and due to that, Hive cannot be used for interactive use cases. It is only supposed to do the batch processing. For example, Hive or Mapreduce is typical. Hive or Mapreduce is typically used for batch processing. So as I mentioned to you earlier, page ranking, the entire backend processing can be done using Mapreduce or similar to Mapreduce. Now, if the use case is more interactive, and if you want to see get the data in interactive fashion, then Hive is not a solution. So Hadoop ecosystem, there is a tool called Impala. And again, if we go to the presentation about Hadoop ecosystem, Impala is a non-Mapreduce tool. Okay, and Impala and Presto both are similar to Hive in the syntax perspective. They both support SQL type of queries, but behind the scenes, they will not use Mapreduce framework to submit the job. They will use non-Mapreduce, which is proprietary to them, to submit the jobs. And Impala and Presto are primarily to read the data in more interactive fashion compared to Hive. And let me start Impala process and try to run a query. So Impala D is command. For Hive, it is Hive. For Impala, it is Impala D. It failed. Okay, let me go to other node. First, let me see whether my cluster it is running or not. So you can use the Cloudera manager to see whether it is running as expected or not. So it is down. That's why it failed. So let me restart it. So you can use Cloudera manager for all these kind of operational activities. Okay. So it will take a few seconds to start. And then we will see.
If we were to run the same query in Oracle, what do you think is going to take a lot longer?
For row count, it might not take a lot longer. It might return in similar. Actually, it can even return much faster because Oracle supports indexes and all those things, and Hive does not support. To do the count, you need not to go to the entire table. You can scan to index, and the results might be faster in Oracle for the 2 GB data set. But if it is a 1 terabyte data, then definitely Hive will be much faster than Oracle because Hive is distributed. Oracle, you can get distributed functionality using parallel, but the Oracle parallel engine cannot scale as much Hive can scale. Okay, we will see this. I will talk about more in detail. I will talk about it more in detail actually when we talk about Mapreduce. Okay, so Impala is started. Now let me start the Impala D command. failed again. It is running, so there is another way to deal with it. So as part of the demo, I want to talk about Hive also. You can click on Hive service and go to Hive web UI, and you can get into Hive. Hive is not part of the Hadoop ecosystem, so if you see the presentation, you will not see Hive in this. But the purpose of Hive is to consolidate all the Hadoop related tools and give a common web interface, and it will come handy in many ways. And you will understand by the end of the course the in how many ways Hive can be leveraged by almost all the stakeholders who want to use Hadoop ecosystem. Okay, so the query editors have Impala. Click on here, and you can select the database. In this case, we want to use cards, and we want to run the query again, Logitech. Okay, click on execute. And the Hive will not be submitted as a Mapreduce job. So you cannot go to the web UI which we have seen earlier to see the results. And if you see the performance, it just took 2 seconds or 3 seconds to process the 2 GB of data. Okay, so that is the purpose of Impala. So if you want to do some interactive querying, you can use Impala and point your reporting interface, BI layer. You can connect to Hadoop system using Impala, and you can do interactive reporting against Hadoop. So that is the purpose of tools like Impala and Presto. They also follow SQL type of syntax, and there is some common points between Hive and Impala, which you will understand when we actually set up Hive and Impala on our clusters as part of the course. But for now, just understand that syntax is different as Hive, and it uses SQL type of queries. And the main difference is Hive is for batch processing, and Impala is for most interactive or ad hoc querying. Okay, then we will see HBase. Okay, so if you think about it, there are primarily 2 operations against any file system or database. One is read, other one is write. Okay, and Hive, in this demo, we have seen the read part of it, reading in real time and using using Impala, and reading in batch using Hive by running this const query. So, but if you want to write in real time into Hadoop, okay, you cannot use the tools which uses the Mapreduce framework because the Mapreduce is again for batch. So there is a tool called HBase which uses non-Mapreduce architecture, and you can actually interact with HDFS in real time while both reading as well as writing. Okay, now I will give you a small demo about HBase, and we will proceed further, and we will understand more in detail about setting up HBase and all those things later. Okay, so let me go back to control node again. And HBase shell will look like this. The command is HBase space shell. And it uses a different kind of syntax altogether because HBase uses key value pair concept. So I will give a small introduction about how about more details about HBase when we talk about it. But as part of this demo, I will simply show you how to put into a sample table and how to get from the table. Okay, let's create a table called Novisync HBase demo. Okay, and you have to give something called column family name. No need to worry about what it is. and just give the table name and column family name. And the major difference between relational database and HBase is that you will not give column names when creating the table. When it comes to relational database, you have to define the structure in create table, and whenever you want to alter table, you have to get it through release management and change the table and refactor your code to point to the to use the new structure, and it's a very long process. Okay, even if the existing code does not impact, still you have to get you have to deploy the DDL changes first, and then you have to deploy the new code. You cannot do it both together. First you have to deploy all your database changes, then only you will be able to deploy the application. So whereas in HBase, you will not specify, you need not specify the column names when you are creating the table. You have to give this is column family name, not the column name. So you have to give the column family name, but not the column name. Don't worry about what column family is at this time, but just remember that when you are creating a HBase table, you have to give the column family name. And then to write data into HBase table, you will use syntax like this, HBase demo, which is table name. And then you have to give a key. So let's say key is A. Okay, and then you can give the column name here, and then column value. Okay, so now if the syntax is put in the command, and this is the table name, which is this one. This is the row key. This is called as row key, and this is the column key, which is the column family name and column name, and this is this is the column value. So this is how you typically do. So when you actually put into the table, you will give the column family, column name as keys, and then values. So you can give any name here. They can even have some business logic embedded in it. So I will explain more in detail when we actually talk about HBase. But for now, these are the primitive operations: creating the table, insert record into a table, and then to see all the records, you can just use scan command, and then scan, and it will show you the results. Okay, and also there is another command called get, but for now this is enough. So this is how it will look like. So you can insert into HBase tables in real time. So the put command to insert that one record is just 2 milliseconds, and to scan that one record from the table also it just took a few milliseconds. And let me run a scan command or count command on a bigger table like this. So you can get count like this. There is so let me see whether there is any big table. But if you use Mapreduce frameworks, even this one will take few seconds. It will not return immediately. So HBase is the tool where you can use the operational but not transactional database to write into HDFS in real time, and also to read from HDFS in real time. Okay, so this is actually have few records. So we are getting the count. And it will take few seconds. So it has 125,000 records, and it took 16 seconds. Okay, so that's how that's a small demo about HBase. And if you want to just get a single record, you can run get command. Scan will return all the records, and get will record only a single record for a given key. So this is how these are the columns that are there in the table for that record. So the column names can change for each record as well. Okay, that is about HBase demo. We will see a lot more details when we actually talk about HBase. Now I will just give you an overview about Sqoop command and Uzi command. Hive web interface I already showed you. Then we will get to the next topic. Okay. So Sqoop is a export and import utility. So if you earlier Chintan have asked me how to get data into Hadoop. So one of the tools to get data into Hadoop is Sqoop. So you can use Sqoop import to get data into Hadoop, and you can use Sqoop export to get data out of Hadoop into relational database. So if you think about it, there is a source and a sink. Okay. So for Sqoop import command, let me show you the syntax of the Sqoop import command. And for this, the source is the table name called small deck, which is in a database called cards, which is a MySQL database on localhost. Okay. And the username is deck and password is the Hadoop to connect to that MySQL database. And this is the table name from which I want to import data, which is a source for my Hadoop to get data for Hadoop. And this is the sink, which is the HDFS directory we need to provide. So this is how a Sqoop import command will look like. And there are other parameters which you need to be aware of a little bit, not in detail. And so you should be, as an administrator, you should be able to run Sqoop commands on the developer's behalf to get data into Hadoop or out of Hadoop. And let us see export command. And this is how export command looks like. And the export command is to get data from Hadoop. So this is source in this case. And the sink is this one. MySQL table under the cards database. And we are connecting to MySQL using the username deck and password Hadoop. And table is deck of cards another. So I'm reading data from this location in HDFS and writing it into MySQL table. So this is how Sqoop works. Sqoop is just to get data from relational databases into Hadoop and also from Hadoop into relational databases. To get data into Hadoop, it is called as import. To get data out of Hadoop, it is called as export. Okay. So it is similar to export import utility which you have seen in Oracle. So you see export data pump, import data pump, and all those things, which is proprietary to just to Oracle. Whereas Sqoop is not proprietary to anyone. It is a generic tool using which you can data from any relational database into Hadoop and also from Hadoop into any relational database. I will not be running Sqoop commands now because I just want to show the syntax. I hope you already understand what is going on behind the scenes for each and every tool. And again, whenever we hear about a tool, you have to go back to this picture. Sqoop uses Mapreduce as a framework to get to interact with Hadoop or HDFS. So in this case, whether it is Sqoop import or export, it will be again compiled into a Java code, and that Java code will be submitted as a Mapreduce job, and that Mapreduce job will take care of connecting to the source database and get data to HDFS. Similarly, export, the Mapreduce job will get data from HDFS to relational database. We will see all those details when we actually talk about Sqoop. But for now, just understand that whenever I spoke about a tool, you need to think whether it is a MapReduce tool or non-MapReduce tool. Understanding this is very important. That way, you will set up your clusters easily. If you don't understand these things, you will get confused and you will make mistakes. So any tool you need to understand whether it is a MapReduce based tool or a non-MapReduce based tool. Okay, now the next one as part of the demo. Yeah. So it's Woozy. So typically in any of the organization, there will be workflows. Okay, so based upon certain action, you have to take certain follow-up action. So for example, if you are using Hadoop or any database for ETL purpose, so typically you might have about workflows where you load certain tables first, and then use the join transformation to join data from those from the previous steps, and then execute some logic and push output to something else. So with any tool, you will have something called workflows. Okay, you don't need to. People from DBA background might not understand what workflow is, but if you try to interpret workflow, flow means you want to do certain work in a particular flow. So it might look like this. Let me do a whiteboard real quick to tell you what a workflow is. So as few of you are from DBA background, even your work has to be done in a flow. First, you have to provision the host, and then our database servers, DB servers, you should get access, and then you have to do the validate, and then you will install. You will set up ASM. First, you will set up ASM, and then you will set up CRS, and then you will set up Oracle other binaries. First after validation, you will do the validation and install binaries, and then set up ASM for storage and CRS. It could be other way around. I did not remember exactly. And then you will create databases, and then you will create services. Okay, and then you will give the JDBC URL to users or connectivity information to users, and they will be connecting to the database. So this is a workflow. Workflow is nothing but this. Similarly, when it comes to Hadoop, don't think about setting up the cluster. In Hadoop context, when I say workflow, you want to do certain things for developers. Developers want to do certain things in a particular fashion. So they have to come up with workflows. So you will not be developing those workflows. Developers will develop the workflows. And then you have to use Woozy tool to run those work. Woozy have workflow scheduler, and also you can submit Woozy jobs. So you have to set up the cluster to support the Woozy. So you just have to understand whether about workflows a little bit, and also you should be able to validate before turning around to the developers. So you will not be developing any workflows for the developers' purpose. They will give you the workflows, and you might have to schedule them using a scheduler. But you need to understand from the perspective of setting up Woozy and then validating it. So you have to understand simple workflow so that you can run them and validate that it is running as expected. And also you should be able to troubleshoot the issues. So you should understand what is going behind the scenes. That's what you need to understand. So let me show you a simple Woozy command, and then we will go to the next topic. So I will share all these things, not all these things, all the commands that are relevant for administrators soon, and you can try these things in the lab. Okay. So in this case, I have templates for Hive, Pig, Sqoop, etc. Let me show one for Hive. Okay, and it has, so this is what workflow is. Okay, and this is how it will look like. So in this case, it's nothing but XML file, and you need not worry about most of these things. The only thing is you need to know that workflows will look like this, and if they run into any issues, you should be able to troubleshoot them from the administrator perspective, why it is failing, like permission issues, storage issues, and all those things. Okay. Again, as I told you earlier, you need to understand what kind of tool it is. It's a MapReduce driven. So when you submit a Woozy workflow, the workflow itself will be running as a MapReduce job. Okay, don't need to worry if you don't understand this. We will see these things in detail when we actually set up Woozy and how to validate whether it is working without any issues before turning around to developers. Okay, so this is about Hadoop architecture. Actually, I have the slide. I thought I missed it. So when it comes to Hadoop architecture, there will be cluster of servers with same binaries and configuration. So in this case, I have 4 nodes, and the binaries are same, and even the configuration files will be same. Okay, and you will see those things later, but it's a correct statement that the binaries will be same. Like Oracle, even in Oracle, the binaries will be same. Majority, but not all of them will have same background process. So that one also you can understand from this web page. Here you have 27 roles, and there are many background processes running here, whereas this one have only 11 roles. But still, your binaries will be same. Only thing is number of processes need not be same. And here also there are 11 roles. So most of the servers, they will be same, but masters will not have as many as slaves. In this case, this one is having a lot more. Typically, this will not be the scenario. Most of the slaves will have higher number of roles than the master. In this case, I have configured this node as both master and slave. That's why it is showing more roles. Let me show another cluster to make it more clear. Okay, this is the cluster in the lab. Okay, and here, even here also there are more roles. That is fine, never mind. Typically, the master will have fewer roles than the slaves. A different number of these roles have to be distributed in production clusters. In this case, I am putting everything in one node. That's why there are too many here. But you will understand more when we actually work on our AWS cluster, which is 16 nodes. There we will actually distribute like we do in production. Okay, the only thing you need to keep in mind is majority, but not all of them will have same number of background process or same background process. And the storage will be typically local file system on all the nodes all the slave nodes in the cluster. Even if network mounted, each mount point will be dedicated to the server. Okay, and the binaries will be installed on all the servers. Parameter files, there will be a bunch of XML files. In Oracle, it will be init.ora, p file, sp file. Those are the parameter files. Whereas in Hadoop, there will be a bunch of XML files, and we will see those as we proceed to further topics. And backend process will be like this: name node and data node. You have seen the terms earlier as well. These backend process or daemon process are for storage, and similarly there are other daemon process for other purposes. And then memory will be same amount of memory on all the nodes in the cluster, and memory structures will be typically JVMs. Okay, network will be one or more network switches will connect all the nodes. So the way it will look like is it will look like this. So you will have data nodes, bunch of them. and then you will have a network switch, and also you will have masters. Masters are our main node, and there will be multiple masters. I will not getting into terms here. So all these things will be connected to a network. So this is a network switch. Okay, so all these nodes will be connected to network switch. So in small size clusters, small to medium size clusters, there will be only one network switch. But in larger clusters, there is a concept called rack awareness, and you can actually set up using multiple switches. And we will see those details when we actually talk about HDFS about the components in detail. So these are the critical differences, batch versus non-batch. Oracle is fine-tuned for OLTP systems which are both operational as well as transactional. Oracle supports batch processing but cannot scale. Hadoop is primarily for batch processing, no transactions as commit and rollback. Okay, I hope this is clear to everyone. Data locality, this is very, very, very important. Okay, and you can expect this kind of these questions in interviews. These two things, data locality and scalability. Scalability I have explained earlier, so I will not get into details. If you have any questions, make sure you clarify on these two things. I will talk about data locality now. I hope everyone is following. I'm getting into whiteboard again, and first let us see how a query will be executed in relational database like Oracle. You have database servers. And you have a network switch, and then you have storage. Okay, so what these database servers will have? They have CPUs. From infrastructure perspective, hardware perspective, they will have CPUs, and they will have memory. They will have storage, but the storage will not be used for the database. So each one will have CPU, memory. Let me use the different colors. Okay, and on top of CPU and memory, it will also have code. So you will have Oracle binaries installed on all these nodes in the cluster. So they will have code as well. So what does that code have? It will have something called SQL engine. What does SQL engine do? It compiles the SQL queries like select count of star from deck of cards. And that query will be passed by the SQL engine, and if the query is valid, then it will be compiled into machine language, the proprietary language of Oracle, and it will start doing the network I/O. Okay, so this SQL engine will compile the code, and will then there will be other modules in the code which will use that query. Means use the compiled code of the query, and it will do the network I/O. And let's say you have a 2 GB table here. So this is 2 GB deck of cards. And when you run this select count of one from a table as a query, this data has to go through this network switch, and wherever the query is submitted, the database server will get that code, will get the data, and it will apply the logic on the data by using the CPU and memory of that node, and it will give the count. So what is happening? The data which is in the storage layer is transferred over the network to the database server, and then it is getting executed. So the data is coming to the code. So if you think about it, right, we have given a query like select count, and the query is probably even after compilation it could be around 2 kilobytes. Okay, so to execute 2 kilobytes of code, we are getting 2 GB of data over the network to the database server. Okay, so this is fine for random access for real-time applications, but for batch processing, this can become overkill, and that is the reason why this is another reason why it cannot scale. So getting data to code is one of the reasons for not scaling linearly, on top of 2 reasons which I have explained earlier. Earlier I have told about the network and also the global, earlier I spoke about the transactions and the global queuing and locking mechanisms, which will make it, Oracle databases not to scale linearly. And this is the third reason, because data has to come to code always, it cannot scale linearly. Now when it comes to Hadoop, when I actually submit, let me see, let me get out of it. When I actually submit the Hive query earlier, which is translated into Hadoop job, Mapreduce job, it has created 9 mappers. And as I explained to you earlier in layman terms, the storage and code are co-located. Okay, so in this case, the data is split into 17 blocks, and they are all on the nodes in the cluster. And when we actually submit them, not all, on many nodes in the cluster. And when we actually submit the job, it uses the data locality concept, which means the job, when I run the query, the code will be compiled and the code will be pushed to all the nodes in the cluster. So even though we are executing from 239 all the queries, the compiled code will be pushed to all the nodes in the cluster. So in case of Hadoop, the code is going to the data, not the other way around, when you, as you have seen for traditional databases. So that is one of the major differences between Hadoop and traditional RDBMSs. In Hadoop, code goes to data, which is called as data locality, whereas in traditional RDBMSs, it's the other way around. Data will come to code. So this is one of the reasons why Hadoop can scale much linearly compared to Oracle, because you will not be transferring data like you do in traditional databases. And we will talk about this data locality again when we talk about Mapreduce and all those things. So you might have got something in this session, but you will understand more deeply when we actually speak about Mapreduce. But it's a very, very, very important concept. If you do not get these 2 things, data locality and scalability, you have to make those 2 concepts clear. So that's it about the Hadoop introduction. Let me know if you guys have any questions. I am stopping the recording because it's almost 2 hours.
On this, Oracle in general